Okay, good morning. This is our warm-up today. This is referencing our ELR from before 10.3 on the area of a polygon. So let's write down that formula again. The area of a polygon is 1/2 times the apothem, which is A, times the perimeter of the polygon. Here we have a three-sided shape, which is a triangle, which is a polygon. We need to find the apothem here. They're telling us the 12.7 is the radius. So that's not the apothem. The apothem is this line that I'm going to sketch in red right here. Okay, so we need to find that apothem, and we also need to find this side length here so that we can get the area of this, or the perimeter of this triangle, my bad. So this is a 30, 60, 90 triangle. So we're given the hypotenuse. So if we take 12.7 and divide it in half, we could get this side opposite of the 30-degree angle, and that would be 6.35. And then this side length up here, opposite of the 60-degree angle, is 6.35 root 3. Now, if you notice, we have 6.35 root 3 also over here. They said they want the answer to the nearest square inch, so I could actually get this in a decimal form. So we're doing 6.35 root 3 plus another one to get what the side length is on this triangle. Okay, so when I did that, put in the calculator, I'm going to leave it kind of long here. 21.997 is the side length. The apothem is the 6.35. So now if we go back to the area formula over here, 1/2 times the apothem times the perimeter now. So the perimeter is 3 sides times that side length. Put it all in the calculator. And I get the area to be 210 inches squared because I said rounded to the nearest square inch. So today we're still working with area of polygons, but now we're going to be using it with our trig ratios. This is ELR 10.5 for your notes, finding area using trig ratios. So let's take a look at the first problem. What is the area of this regular nonagon? 9 sides, round to the 10th place. So let's take a look. Which side is the radius here? So I'm going to do it in red. Right here is the radius. From the center to a vertex, this is the radius. Which is the apothem? Let's do that in blue. This is the apothem right here. Well, we could get the perimeter because we know it's 10 all around, so that's easy enough. The perimeter we know is going to be 10 times 9, which is 90. But we need to get the apothem. So let us talk about what we did the other day with regular polygons. We would take 360 degrees, divided by the amount of sides, then divide that in half. I'm getting 40. Divide that in half. I'm getting 20 degrees. Now, where is that 20 degrees? I'm going to take out this triangle that I made here so that we could see it. Here's the apothem. Here's the radius. Here's the bottom piece here, the right angle. So the 20 degrees is right up in here. How much is this black line? If the whole side is 10, this has to be 5. So I need to find my apothem right here. So I'm looking at 20 degrees with respect to A and 5. A is adjacent, 5 is opposite, so that means I'm going to be using tangent. So tangent of 20 degrees, opposite over adjacent, 5 divided by A. Now I do our cross multiplication, and then we go ahead and divide by tan 20. Okay, since it says the 10th place, I get 2.2 for the apothem. So now let's go to our area formula. I think we have everything we need. 1/2 times the apothem times the perimeter. So 1/2 times 2.2 times the perimeter, 90. And I get the area of this nonagon as 99 centimeters squared. So here we had to use trig to find one of the missing pieces for our area here. And we have a couple more examples. Here we have find the area of this polygon rounded to the 10th place. This is 5 sides, a pentagon. So this one is missing 2 pieces here. 3 is the radius. This is the radius. My apothem is this one right here. Don't have that one. And I don't have the side length. Let's do that one in red. I don't have this here. So we need to find two important pieces here. So to start, let's go ahead and get the angle on the top. 360 divided by 5. 72. Divide that in half. 36 degrees. So if I take out that triangle, which I'm going to do here, let's see it by itself. This is the apothem. We got our radius, which is the hypotenuse. And then we have this piece of the side length down here. So 36 degrees is right here. The radius was 3. All right, so I still need to find my apothem. And I need to find this length here and double it. All right, so let's go ahead and use 36. Let's find the apothem first, the A. So A is adjacent to 36. 3 is the hypotenuse. So that's cosine. So cosine of 36, adjacent over hypotenuse. Okay, when I cross multiply, I get it to be 2.4 is my apothem. Now to find x. X is opposite of 36. 3 is the hypotenuse, so this is sine. So I'm going to be doing sine of 36. My opposite over the hypotenuse. I get the x side length to be 1.8. This is 1.8. So if I put it back in the picture here, remember I need the whole side length because I need the whole perimeter. So 1.8 plus 1.8 is 3.6. So I think we have everything we need to get the area. Area is 1/2 times the apothem times the perimeter. So my apothem we got to be 2.4. Perimeter is going to be 5 sides times 3.6. Area comes out to be 21.6 feet squared. Okay, here we see these all the time on the streets. Stop sign, which is an octagon. The standard size has a 16.2 inch radius. What is the area of this stop sign to the nearest inch? So let us make this triangle. I'm going to make one in here since we don't have one. And what does it have? The standard, the radius, which is this black line that I drew, is 16.2 inches. So again, we got to figure out my apothem. And I have to figure out the side length here. Okay, so let's go back. 360 divided by 8, which comes out to 22.5. So I'm going to take out a piece of this so that we can see it all. Okay, the radius here is 16.2. Okay, this right here is 22.5 degrees. So I'm looking for my apothem, and I'm looking for part of this side length here. So I'm going to be doing those same two functions again, cosine and sine. Okay, so if you pause the video, here are my two answers here. I'm getting down here to be the 15, the apothem. The piece of the side length is 6.2. So this is 6.2. We have another 6.2. So if I add them together, the side length, so I could get the perimeter, is 12.4. So area is 1/2 times the apothem times the perimeter. Well, the apothem we got was 15. The perimeter, we have 8 sides for the stop sign times the side length, 12.4. All right, so the area of the stop sign is 744 inches squared. All right, last thing that I'm going to talk about is, what if we have a triangle and we need to find the area of it, but we don't know the height? So looking at this triangle, take a look. We have 16 inches as the base. We got the base, but they don't have a height. So let's sketch in the height, the altitude here. So if I go from the top vertice down to the bottom, right, that's going to make a right triangle here. So thinking about it, I could get this height length by using what function from trig? H is opposite of 34. 10 is the hypotenuse. So I could find the area. So if I do sine of 34, H over 10, I get the height to be 5.59 inches. We know the base is 16. And we know what the area formula for a triangle is, right? Base times height divided in half. So if I go ahead and do 16 times that, divide it in half, I get the area to the nearest square inch is 45 inches squared. So that's one way of doing it with 2 steps, using sine for that sandwich and then plugging into the area formula for a triangle. Well, now they did a whole proof of this. They actually got a formula, and this is the formula for the area of a triangle given the sandwich SAS. So the area of a triangle is equal to half times the 2 sides I'm making the sandwich with the included angle in between them as the sine of that angle. So I could redo the one that we just did. So make sure you write that down in your notes. So I'm going to do area is 1/2 the 2 sides that make the sandwich, 16 times 10, and then sine of that angle in between. So we're basically doing what we did on the previous page there. And I get the same answer, 45 inches squared. So it's the same thing, just a little shortcut to think about.